Okay, so we did the warm-up. You guys got this, oh, you can't see what I'm looking at. Should have this on your page, 7.4 division property of exponents. You should also have the objectives to divide powers with the same base and to raise a quotient to a power, okay? Now, underneath there is where we're gonna start, okay? And I want you guys just to pay attention. Don't write anything down right now. I'll give you a second once I'm done, but I want you guys to just follow along with me for right now, okay? So don't write anything down, just follow along. Let's take 4 to the third over 4 squared, okay? 4 to the third over 4 squared, okay? And it's lagging, so hold on. Oh, there we go. All right, 4 to the third over 4 squared. What is 4 to the third if we wrote it all out? Roy? 4 times 4 times 4. And Angelina, what is 4 squared if we wrote it out? 4 times 4. Okay? Could we cancel things? What could we cancel? Nicole?
2 of the 4s from the numerator and 2 of the 4s from the denominator.
Excellent. 2 of the 4s from the numerator and 2 of the 4s from the denominator. So what would we be left with? Just 4 over 1, right? Which is just 4 to the what power? The first power, okay? If you don't see an exponent, it's always 1. Beautiful. And now it went black. Hold on, give me a sec. Okay, make sure you're not writing anything down, right? Not yet at least. You will copy this down, but just not right now. Okay, and we're back. Let's do another one. Let's do 4 to the 5th over 4 to the 2nd. So this is going to be 4 times 4 times 4 times 4 times 4. Agreed? Over, Janessa, what is 4 squared expanded?
4 times 4.
Mm-hmm. And just like Nicole said, let's cancel out some stuff. What are we going to cancel, Angelina?
2 4s.
Yep, 2 4s. 2 from the top, or the numerator, and 2 from the denominator. So, Victoria, what am I left with?
3 4s.
3 4s. So 4 times 4 times 4, which is the same as 4 to the third. Okay, so we just did 2 problems. Does anyone notice a pattern that's happening? Giancarlo, what do you see? Ah, we're subtracting the exponents. Look at the numerator for this one. It was 3, right? And the denominator was 2. The exponent was 3 and the exponent was 2. What's 3 minus 2? 1. Take a look down here. What was the numerator exponent? What was the denominator? What's 5 minus 2? Fancy, right? Now copy it all down. Now copy it all down, okay? Guys, you should have nothing electronic on your desk. So if your phone's out, put it away. Don't want to see those, okay? If your iPad's out, put it away. You should have nothing electronic on your desk. Jason, Angelina, and Gianni. I can't see you guys. Make sure I can see you at all times. Adjust your cameras. Jason. Oh, there you are, Jason. And Gianni. It's not going to work, Gianni. I'll need a little bit more from you. Okay. Is everyone done copying this down? Okay. So the rule that we're going to use, guys, is whenever you have the same base, same base with division, subtract exponents. Same base with division, subtract exponents. All I want you to copy down is dividing powers with the same base. So what I highlighted in red, this sentence, and these two examples. Those three things. Dividing powers with the same base. That sentence, to divide powers with the same base, subtract the exponents. And those two examples. Carlos, whenever we're taking notes, you can sit up there, okay? All right, so I want you guys to copy down B. And we're gonna solve it. Okay, so how many variables do we have in this problem? How many different variables do we have? 2, right? We have an M and an N. So I just want you to write an M and an N on your paper and put some space in between so you have space for the exponents, okay? So M, we're gonna start with the numerator exponent, is 2, right? So we're gonna take that 2 and just write it next to the M. What we're gonna do is we're gonna take the exponent on M in the denominator and subtract it from the one in the numerator. So this is gonna be 2 minus 5, okay? Then we're gonna do the same thing for N. So N's exponent in the numerator is 4. So we're gonna take the 4 and we're gonna subtract 3 from it. So this is gonna be 4 minus 3, okay? You guys with me? Okay. Now, all we're gonna do is simplify a little bit. So we're gonna simplify those exponents. What is 2 minus 5? Negative 3, okay? So M to the negative 3 power, N to the first power, okay? Can we simplify this more? How? Very good. We need to move that M to the negative 3 to the denominator, right? Because we can't have a negative exponent. We cannot finish our problem with this and be like, okay, we're good. No, we're not good, okay? We're never good if we have a negative exponent. So this M to the third is going to be written as, we can still write N on the numerator, because that's going to stay the same. It's a positive exponent, so it's just going to chill, over M to the third. okay? Whenever you have a negative exponent, you want to move that term to the denominator. So this is a nice, pretty clean answer. Now, take a look at where we started, right? And where we ended up. Do you see how m to the 5th, that's the bigger one, is in the denominator, right? And m squared is in the numerator? Whichever one's bigger, that's where you're going to end up. Do you guys see that? See how m cubed was in the bottom at the end? Always double check that. N to the 4th is bigger than n cubed, right? So that's why we ended up in the numerator, okay? Whichever one's bigger, that's where you're going to end up because you're going to have an extra one that you can't cancel out. All right? Let's do 2 more problems. So I want you guys to write this one down. X to the 3rd over x to the negative 2. X to the 3rd over x to the negative 2. Okay, who thinks they know how to set this one up? Nicole?
Do x, so 3 exponent minus negative 2.
Ah, very good. I'm so glad that you said minus negative 2. A lot of people will just do 3 minus 2 here, but it's minus a negative 2. Do you guys see that? Because our exponent in the denominator was negative, we have to subtract a negative number. What's the same as subtracting a negative number? Just adding. So this is actually x to the 3 plus 2, which is going to give me what, Janessa? X to the 5th. Interesting, right? Okay, one more, and then we'll move on. 3 squared over 4 squared. Say that one more time, Mariani. Nothing? What do you guys think? Tessa?
So it's going to be 8.
Can we subtract the exponents here?
Oh no, you have to add it because this is
No. Rioni, what do you think?
We have bases.
What's that?
We have the bases.
We have different bases. Do you see how the base on the top is a 3 and the base on the bottom is a 4? We cannot subtract these exponents. We should not get 3 to the 0, okay? We're just going to leave it the way that it is. What is 3 squared? 9. What is 4 squared? Just leave it like this, okay? The reason we couldn't combine these is because we have different bases. Okay? You cannot add or subtract the exponents when your bases are different. Who knows the schedule for today? We are going to do D and E.
Oh, come on.
Oh, come on. I want you guys to do them on your own, okay? Copy down D, copy down E, and give it your best shot. Y to the 4th over Z to the what?
Wait, no, not like that.
Oh, they're both in the numerator. Oh, no. Ugh. Oh, well. Y to the 4th, Z to the 7th. That I agree with. Did anyone else get that?
Well, I'm gonna add.
What happened to x? Nicole, what happened to x?
I put 1 y to the 4th.
That would also be correct. If you put 1 y to the 4th, that would also be correct. But remember, whenever we multiply by a 1, we don't need to write that, okay? Because 1 times anything is just itself, right? It's kind of like invisible. It's there, but you don't see it all the time, okay? So y to the 4th, z to the 7th is the part that I was looking for. Very good, okay? So first, we start with x, right? X has a 4 in the numerator and a 4 in the denominator. So we would do x 4 to the 4th minus 4, right? We would do y to the negative 1 minus negative 5. And we would do z to the 8th minus 1.
Well, that's not negative 4.
No.
Oh, I thought it was a negative 4.
Oh, that's how you got, okay. So from here, we would get x to the what? X to the 0, y to the 4th, because that's negative 1 plus 5, which is 4, and z to the 7th. This is always 1, so we can just cancel it out, okay? And then this just becomes y to the 4th, z to the 7th. Why don't we move anything to the denominator? There's no negative exponents, so we just leave it like that. Nayla, video. Okay. Any questions?
Could you move back to D?
To B? Yeah.
Yeah, to D.
To D? There you go. What happens when you raise a fraction to an exponent, okay? What happens when you raise a fraction to an exponent? Now, technically, we could have already figured this out based on what we've learned in the past, okay? But all you do is you take the exponent outside and you multiply it by whatever's on the inside. What's the exponent of that 5 down there? 1. Okay? So what we're going to write is z to the 2 over 3 times 3 over 1. Because this 3 is getting multiplied by that fraction. So it's 3 times 2 over 3. Over 5 to the 1st times 3. In my numerator, we've got z to the 2/3 times 3 over 1. What are we going to get there? Z to the 2nd. Y. The z's cancel out. This is just 2 over 1, which is just 2. You don't have to write it as 2 over 1. Over 5 to the 3rd. Now, what can we simplify? Do we know what 5 to the 3rd is? Or can we figure it out? Yes. 5 squared is what? It's 25. 5 times 5 is 25. We multiply that by 5, what are we going to get? 125. Now, sometimes you're going to have to actually do the multiplication. So 5 times 5 is 25. Bring up the 2. 5 times 2 is 10. Add 2 to that and you get 125. Okay? So this is simplified to z squared over 125. And yes, guys, you're not going to have a calculator. So anything to the 3rd or the 2nd power, I expect you to actually multiply it out and get that. Okay? Anything to the 2nd or to the 3rd power, I expect you to actually multiply it out. So what's our answer? D. Okay? D is our answer. So, do you remember when we had like two terms, like 4x squared, and we raised this to the third power? Remember how we would distribute this 3 to both terms, both exponents? Same thing. We're distributing it, but both to the numerator and to the denominator, okay? What is the simplified form of a over 5b to the negative second power? Okay, we're missing some exponents though. What's the exponent of a? What's the exponent of 5? What's the exponent of b? 1. All of these exponents are 1, okay? Whenever you don't see it, it's always 1, right? Okay, so we're going to take this negative 2, and what are we going to do with it? Distribute it to what? The ones, right? All the exponents. So to this one, and to this one, okay? So we're going to get a to the negative 2 over 5 to the negative 2, and b to the Ashton, what's up?
Since it's in parentheses, wouldn't the 5 wouldn't the 5 and the negative be together?
No.
Oh.
I see what you're saying, but remember, like even if we wrote 5b squared, you still distribute this 2 to both exponents, right? Now if it was 5b squared, what's my base? B, right? So the squared is only on the b, not the 5. But when they are in parentheses, just like you said, 5b is our base, so we have to square both of them, okay? Okay, can we simplify this? Yeah, well, everything has a negative exponent, right? So we're just gonna flip the entire thing. If every single thing has a negative exponent, it's all gonna get moved around. So this a is gonna be brought down, this 5 and this b squared is gonna be brought up. So let's just reverse it. Let's write it as 5 squared b squared over a squared. Do you guys agree? Anything with a negative exponent needs to be moved to the other side of the fraction. So we just changed it, okay? There's one more thing we can simplify. 5 squared, which is what? 25. So this answer is 25b squared over a squared. Once you copy down that one, that is it, people.